Hi, in this section we'll be adding and subtracting rational expressions. But in order to add and subtract rational expressions, just like adding and subtracting fractions, you need a common denominator. So let's talk about how to find common denominators. So the first term we want to make sure we know is this term called a least common multiple, sometimes referred to as the lowest common multiple. That's abbreviated as LCM. So the LCM of numbers is the lowest multiple of two or more numbers. So before we introduce variables to this, let's just practice a few. The LCM of 4 and 6 is 12. So that is the lowest multiple that 4 and 6 have in common. The lowest multiple for 10 and 15 is 30. The lowest multiple for 5, 12, and 20 is 60. And the lowest multiple for 9, 21, and 63 is 63. So be careful not to confuse LCMs with GCFs. So in comparison, the GCF of 4 and 6 is 2. The GCF of 10 and 15 is 5. The GCF of 5, 12, and 20, well, that's just 1. That's the only number that those three numbers have in common that are divisible, that this number is divisible by. And the GCF for 9, 21, and 63 is 3. So you need to understand the difference between GCF and LCM. Remember, we were looking for GCFs when we were factoring polynomials, but we need LCMs in order to add and subtract rational expressions. Okay, so what happens when you have variables? The LCM of a variable expression is the product of the following. It's the LCM of the coefficients, so that's exactly what I described above. Coefficients are numbers. The factors that they have in common raised to the highest exponent, that's important to remember. And then all other factors that they don't have in common. So sometimes it will be the product of all three of these things. Sometimes it's just one or two of these things, depending on what the factors look like. So let's try some examples. Find the LCM of 3x squared y to the third and 9xy to the fourth. Well, the LCM of 3 and 9 is 9, so that's first. They have x's in common, but you want the one raised to the highest exponent, so that'll be x squared. And they have y's in common, but you want the one raised to the highest exponent. Well, that's y to the fourth. There are no other factors that they don't have in common, meaning like a z variable or something like that. So your LCM is 9, x squared, y to the fourth. Okay, let's move on to the next one. Here I have 12, a, b, c to the fifth, and 4, a squared, b to the third. So the LCM for 12 and 4 is 12. They have an a in common, but you want a squared, the one raised to the highest exponent. And they have a b in common, so you want b to the third, because that's the highest exponent. And then you also want to multiply it by the part they don't have in common. Well, they don't have a c in common, so you multiply it also by c to the fifth. So your LCM is 12, a squared, b to the third, c to the fifth. Okay, in this next one, I have some binomials. So I have 3x plus 5 squared and 6x plus 5 times x minus 1. Here's your LCM. The LCM of 3 and 6 is 6. They have an x plus 5 in common here and here. You want the one raised to the highest exponent, so you put x plus 5 squared, and then whatever they don't have in common, which is x minus 1. So your LCM is 6 times x plus 5 squared times x minus 1. All right, last example is here in orange. I have x squared minus 16 and x squared minus 3x minus 4. Before I can identify what factors they have or do not have in common, I have to actually factor these. So x squared minus 16 factors to x plus 4 and x minus 4, and x squared minus 3x minus 4, well, that's x minus 4 and x plus 1. So they definitely have an x minus 4 in common, so that goes first. And then they do not have an x plus 4 in common, and they do not have an x plus 1 in common. So those also get attached here to this product for LCM. So your LCM is rather long, but it is x minus 4 times x plus 4 times x minus 1. Okay, so those skills will help us when we're talking about LCDs. An LCD is basically an LCM, but it's referring to the denominator. LCD stands for least common denominator. So we want to identify the LCD and rewrite each rational expression with that common denominator. So my denominators here are 15 a squared b and 20 a cubed c. So the lowest common multiple for 15 and 20 is 60, which I wrote here on the right. They have an a in common, but you want the one raised to the highest exponent, so it's a cubed. And then they do not have b in common, so that goes along with the LCD, and they do not have a c in common. So my LCD is 60 a cubed b c. All right, now the second part, rewrite each rational expression with that LCD. That just means to multiply each fraction by whatever's needed to make the denominator look like this. So what am I missing in the first one? So I have to multiply 15a squared b by 4ac so that it is 60 a cubed bc in the denominator. But whatever you do to the denominator, you must also do to the numerator. So again, it's like multiplying by 1. We've talked about that before. So multiply numerator and denominator by 4ac. So my new first fraction is 8ac over 60a cubed bc. Now for the second rational expression, in order to get the denominator of 60a cubed bc, this denominator must be multiplied by 3b. And again, whatever you do to the numerator, whatever you do to the denominator, you must also do to the numerator. So my second fraction is negative 3b over 60a cubed bc. Okay, let's move on to another one. Same instructions. We want to identify the LCD and then rewrite each expression with that common denominator. So here we cannot just pick out the LCD right away. We must first factor this trinomial so that we can see what the common factors are. So looking for two numbers that multiply together to give me negative 8, but when you add them, you get 7. That'll be 8 and negative 1. So that means you're actually subtracting to get 7. So I write my first rational expression as 3x over x plus 8 times x minus 1, and the second fraction stays the same. So you can see that they have a common factor of x minus 1 and one that they don't have in common, which is x plus 8. So my LCD is right here, x plus 8 times x minus 1. Okay, so that means that I already have this common denominator in my first rational expression, so there's really nothing you have to do there. You just copy it down. But the second one, well, that one is missing the x plus 8. So you multiply the numerator and the denominator by x plus 8. And when you do that, in the numerator, you get x times x plus 8, which gives me x squared plus 8x. And my denominator then becomes the common denominator of x plus 8 times x minus 1. Okay, so now that we know how to find lowest common multiples and least common denominators, we can actually start adding and subtracting these rational expressions. So let's look at number 1. We have negative 3 over x squared y cubed plus 5 over x y to the 4th. So first let's identify the LCD. My LCD is x squared y to the 4th. Now I must multiply each rational expression by whatever's missing to get that denominator to be x squared y to the 4th. So the first one must be multiplied by y, so that my y cubed will become y to the 4th. And my second expression, well, that one has to get multiplied by x, so that my x becomes x squared. All right, so in the next line, I actually did that multiplication. And once you do the multiplication, you then have a common denominator, so you can write it as a single fraction instead of two separate ones. So you have negative 3y plus 5x over x squared y to the fourth. And you're done. With rational expressions, you should always check to see if there's anything you can simplify. You cannot here, so the answer is in the boxes as far as you can go. All right, so now we have number 2. I have z over z squared minus 2z minus 48 minus 6 over z minus 8. So again, before I identify the LCD, I must factor this trinomial. And this factors into z minus 8 and z plus 6. The negative 8 and the positive 6 gives me negative 48 as a product. But when you add these, you get negative 2 as a middle term. All right, so now that I see my factors, I know that my LCD is the one they have in common, z minus 8, and the one they don't have in common, which is z plus 6, which means the first fraction does not change. It already has the common denominator, but the second one gets multiplied by the missing factor, which is z plus 6. All right, so in the next line, I have to multiply this 6 here, which is what you see right here, that I'm going to be multiplying the minus 6 times z plus 6, but I've also rewritten it as a single fraction instead of two separate ones because now they have their common denominator. Okay, so in this next line, I actually do the distribution. So I have 6 minus 6z minus 36 over the common denominator. Combine like terms, so you get negative 5z minus 36 over z minus 8 times z plus 6. And you can leave it like this, but it probably looks better if you factor out a negative from the numerator and put it in front, like I did right here. And that means that this term here changes to positive. So these two are equivalent. They mean the same thing. So either format is fine in terms of how you leave it. I just prefer the one in the box. I think it looks better. All right, so here's another one. I have x plus 4 over x squared minus 3x minus 18 plus 2 over 6 minus x. So first thing I did was factor. X minus 6 and x plus 3 work. But notice that I have x minus 6 here, and here I have 6 minus x. Well, they look almost the same, except they're off by a negative. So what I did was I took a negative out, so this plus became a minus, and then my two terms in the denominator flip signs. So the minus x becomes an x, and the 6 becomes a minus 6. So now it makes it easier for us to identify the LCD as x minus 6 and x plus 3, because now they have x minus 6 in common. So if you can apply that trick, that's a good idea. So again, the first expression stays the same. It already has a common denominator. The second one gets multiplied by the missing factor, x plus 3. Then I wrote it as a single fraction, showing that I need to still distribute the negative 2 across x plus 3. And then here I did the distribution. So I have x plus 6 minus 2x minus 6. And x minus 6 is negative, x minus 2x is negative x. 4 minus 6 is negative 2. So again, this answer is fine, but I did the same thing I did in the previous example, which is to factor the negative out and put it in front. That means this changes to a plus. So again, these two expressions are equivalent, just different formats of expressing the answer. Okay, so let's move on. This time I have 3 terms. So I have 5 over 2y plus 8 over 3y minus 8 over 5y. So I'm looking for the LCD of all of my denominators. So the lowest common multiple of 2y, 3y, and 5y is 30y. So now I have to multiply each expression by what I need in order to make that denominator 30y. So the first one will get multiplied by 15 over 15. The second one gets multiplied by 10 over 10. And the third one gets multiplied by 6 over 6. Again, that's because 2y and 15 is 30y. 3y and 10 is 30y. 5y and 6 is 30y. Remember, your goal is to get a common denominator. Okay, so let's actually do that multiplication. Remember, you have to do the multiplication in the numerator and the denominator. So here you get 75 over 30y plus 80 over 30y minus 48 over 30y. Since I now have a common denominator, I could write this as one big fraction as 75 plus 80 minus 48 over 30y. The numerator simplifies to 117 divided by 30y. In that case, you do have to simplify because 117 and 30 have a common factor of 3. So if you divide them both by 3, you will get a 10 here and a 39 here. So your final answer is 39 over 10y. And that's it for this section. So give the homework a try. Good luck.